Greetings, students, and welcome back to this week's edition of Distant Learning with Mr. Wong. In Monday, May 11th lesson, we're going to discuss graphing proportional relationships. Take a look at the graphic and take a look at how the graphs look. Which one of these is proportional, meaning a constant rate of change? Let's investigate and interpret these before we go into the homework. Graphing proportional relationships. Recall that you can graph the values from a ratio table, comparing x and y. The first point is time and in height 3, 2, 3 across, 2 up. Next point is 6, 4, then 9, 6, and 12, 8. If we were to connect these dots in a straight line, we'll see that is a constant pattern. Every 3 seconds, the height changes by 2 meters. And it will continue on beyond this graph. This is what a proportion will look like visualized on the graph. Note, the graph of every proportional relationship is a line that runs through the origin. It has to go from 0, 0 before it moves up. That is a necessary tip. Let's investigate two problems and see if they're proportional or not by looking at the graphs. Use a graph to tell whether x and y are proportional relationships. Our goal is to plot these 3 points and draw a line through the points. Doing so, we do have a straight line of constant rate of change. However, the graph of the line does not pass through the origin. So, x and y are not a proportional relationship. How about for table B? Let's plot 1, 2, 2, 4, and 3, 6. If we connect these dots and continue, the graph is a line that does pass through the origin. So x and y are proportional relationships. If you recall from last week, we can always just compare the two ratios and see if we can use cross product to see if we get the same answer. Let's compare 2, 6 and 4, 8. Let's cross multiply and do 2 times 8 to get 16. Is that the same as 6 times 4? No, 24 is not equivalent to 18, so it's not proportional. How about in part B? Is 2 times 2's cross product the same as 1 times 4? It is. They're both 4. How about 4 and 3's cross product? Is it the same as 2 and 6? It is a result that they're both equal to 12. So we can test proportionality without using the graph, but if given a graph, we can answer the question if the relationships are proportional or not. And now it's your turn to practice. I want you to use a graph and tell whether or not the x and y are proportionate. You may start by drawing yourself a graph with just the x and y axis and marking little dash marks to make these whole numbers. In part 2, you'll have to make half tick marks to do this properly. You can also double check to see if you have cross product to see if they're proportional as well. Pause the video now to create graphs and then compare your work to see if the results are the same. Welcome back. Let's take a look at the graphs. If you were to plot the points 1, 3, 2, 4, 3, 5, and 4, 6, and then connect the dots all the way back to the y-axis, you'll see that it does not go through the origin, so it's not proportional. Doing the same thing for number 2, drawing the dots and connecting them all the way making a straight line, we do see that it hits the origin. So yes, this is proportionate. Now what if we were given a graph? Could we interpret that information? Let's find out. The graph shows that the distance traveled by the Mars rover Curiosity is proportional to the time traveled. Interpret each plot point on the graph. 0, 0, by interpreting this, means that the rover traveled 0 inches in 0 seconds. At the next point, 1, 1.5, the rover travels 1.5 inches in 1 second. So the unit rate is 1.5 inches per second. At 3, 4.5, the rover travels 4.5 inches in 3 seconds. Because the relationship is proportional, you can also use this point to find the unit rate. Comparing the ratio of 4.5 to 3, if we divide both sides by 3 to get our 1 second on the denominator, do the same thing by dividing by 3 in the numerator, and we get the same rate as this 1.5 meters inches per second. In the graph of a proportional relationship, you can also find the unit rate from the point 1 and whatever value is here, because it's per x. So interpret each plotted point on the graph of this proportional relationship. Again, it'll be earnings per hours worked. At each point, 0, 0, 115, and 460, I want you to make your interpretations and write them down. You'll have 3 responses, again, for 0, 0, 115, and 460. Pause the video to accomplish this task and resume once you finish to compare your results. Hello, welcome back. Let's see if yours match the interpretation here. At 0, 0, you earned $0 for working 0 hours. That makes sense. At 115, you earned $15 for working 1 hour. This point represents the unit rate, $15 per hour. At 460, you earned $60 for working for 4 hours. Because the relationship is proportional, you can also use this point to find the unit rate, $60 for 4 hours. If you divide both sides by 4, you'll also get 15 per hour. And let's take a look at one more problem. Interpret each plotted point in the graph of the proportional relationship. 0, 0, 1, 5, and 630. Remember to use the language in the previous example, identifying the unit rate, but also indicating that you can use another point also in a proportional relationship to find the unit rate. Pause the video now and write a description interpreting these 3 points, 0, 0, 1, 5, and 630. Then resume the video once you've completed the task. Welcome back. Let's take a look. Again, 0, 0 represents that the balloon rises 0 feet in 0 seconds. At 1, 5, the balloon rises 5 feet in 1 second. This point represents the unit rate, 5 feet over 1 second, or 5 feet per second. And finally, 630 is interpreted as the balloon rises 30 feet in 6 seconds. Because the relationship is proportional, you can also use the point to find the unit rate. 30 over 6. Divide both sides by 6 to get 5 over 1, or 5 feet per second. Homework is an MFAS task document. Go ahead and click on the homework link for May 11, 2020 to download and complete. You can work on a sheet of paper, but always copy the problem before solving. You are not required to draw the graphs. You may also print out and work the homework problems out. Homework is due by Tuesday evening, May 12, 2020, 11:59 p.m. Until next time.